Hey, what is up? And welcome back. Hello, hello. This is about circles. We are learning a little bit about circles today, and I will draw a circle. First thing you need to know is, what is a tangent line? A tangent line only touches the circle in one spot. Mathematicians love to say that. How can it touch the circle in one spot? Well, in a weird sense, circles stick out. What do I mean by this sticking out? Well, they're kind of pooching out in every direction. So there is one point that's sticking out further than all the rest, and that one point is where that line is going through. So it's only going through one point. If it teeter-totters at all, it'll go through two. So if let's say you start with a tangent line, but then you rotate a little bit, now it's going through two, and the thing is that happens immediately. It's just you have to zoom in really far, but it'll immediately go through two once it's no longer tangent. Well, what is the special line? It is the special line. It is a line that is perpendicular to a radius, perpendicular to a radius line, a line that is on the radius or the diameter, a line that goes through the center of the circle, and at the edge of the circle, a perpendicular line is the tangent line. And it only touches in one spot there. Okay. So, it is possible to have a circle and to have a line, a tangent line specifically, and I should have drawn that continuing off into the sunset. There we go. And let's say, ooh, wow, my tangent line failed. Let's just say it goes through there, and there's the other point. This situation now has the 360 degrees of the circle divided up into this arc and this arc. One's bigger than the other. The big one's called the major arc. Some people call it the far arc, and this is the near arc, but major and minor is way more common. Minor arc. And then this is small. Let's say this is like 5 degrees-ish, around 5 degrees. Now, how much, we're trying, let's say we don't know what this is. Oops, I'm not on the screen. Good thing I wasn't on the screen. Let's say we don't know what this is, but we want to know what it is. Can we use our knowledge about these arcs? Let's say we knew, how big is this arc? Well, it's more than 180 degrees. It's more than half of the circle. Let's say it's 190. And then this has to add up to 360. So 360 minus 190 equals 170. So this arc's 190, this arc's 170. And then what do you think this angle is? Well, let's say it's about 5 degrees. Is there a way we can turn 190 and 170 into a 5? Well, if we do 190 minus 170, then we get to 20 degrees. That's kind of close to 5 degrees. Let's, if I was more like, if this was, I'm estimating here, so if I estimated this differently and said this was 195 and this was 175. Wait. 185. Getting them closer together. 185 minus 175 is 10. That's even closer. So something like subtracting might get us close here. Now let's go to the other extreme. Let's put the tangent lines really close. Now what is this angle? Well, this is like most of the circle, right? Let's say this is like 350 degrees of arc, major arc. That would leave only 10 degrees here. That's more than 10 degrees, right? So let's say this is 140. And this was 20. Now if we try to do our major arc minus minor arc, 340 minus 20, it gives us 320. Now this angle is not 320 degrees. It's closer to like 160. It's more than 90. I mean, it's a big angle, right? It's more than 100, more than 110, maybe 150, maybe 160. Let's say it's 160 degrees. How can we turn 320 into 160? Divide it in half. Let's see if that would work here. If we subtract the major arc and the minor arc, we get 10 degrees. But then if we divide it in half, then we would get our 5 degrees. So that is the formula. It's the major arc minus the minor arc divided in half. All right. There's one other situation, which is what if the angle is on the circle and now these are not tangent lines, these are secant lines. Let's say that's 4 degrees of arc, and this is a 2-degree angle. Okay, nice. Now let's do one more circle. Let me divide the circle in half. And interestingly enough, no matter where I put this angle on the circle, it's going to be a 90-degree angle. That's kind of mysterious, but it's just the way that circles are. If you don't believe me, I'll put it way over here. But look at that. It's also making a 90. Doesn't matter where I put that angle on the circle's rim. If the two arms of the angle go through those 2 points, it'll make a 90. So that means 180 degrees of arc turns into 90 degrees of angle. These are called secant lines, by the way, because they're not tangent, they just go straight through. And if your angle is on the circle, then the formula is just the arc, the captured arc, divided by 2. The secant angle equals the captured arc degrees divided into 2. And the tangent angle equals the major arc degrees, subtract the minor arc degrees, divide that by 2, and that is degrees of the angle. Let's do a quick example. Whoop. Wait a second, Mr. Avden. You just gave us the arc and asked us to find the angle, but now we give us the angle and have to find the arc. Well, we just use some algebra. Remember, it's captured arc. So this arc, which is x, divided by 2 equals 74 degrees. Do some algebra, times 2 times 2. The captured arc must be equal to 148 degrees. What about going forwards is? Formula is captured arc divided by 2. Then, oh, we should write it like this. The measure of angle EFG equals 45 degrees. Okay, what about that tricky one? Number 7. Well, first of all, we need to know the minor arc. We have the major arc. How are we going to find the minor arc? So that's 125. The measure of angle VUT equals 55 degrees. Let me double check that. Yes. Okay. Last one. This one, we want to know what this arc is. We have this angle. But remember, when we get this angle, the last thing we do is divide it in half. We do major minus minor divided by 2, and that equals 55 degrees. So we could times by 2, times by 2. We have major minus minor equals 110. Now we have to do a system because we also know that m plus m equals 360. So we could solve this system, or should we solve the system real quick for fun? Yes, we shall. Plus m, plus m. Major equals 110 plus minor. So now we swap that into this major. So we do 110 plus minor equals 360. So we subbed into this, but there's that one sitting right there. So 110 plus 2m equals 360. Subtract 110. 2m equals 250. Divided by 2, and minor equals 125. That's what we wanted right there. Another way to think of this is, if the major and minor were both 180, then their difference would be 0. And when you cut it in half right here, it would equal 0. But it doesn't equal 0, it equals 55. So that means they have to be different by 110. The major and minor have to be different by 110. But remember, being different by 0 is 180, 180. So you just start at 180 and add and subtract 55. That would give us 235 for the major and 125 for the minor. So you can solve the system like this, or you can just take 180, subtract 45 to get this one, add 45 to get that one. And then double check your work by taking the major and subtract the minor and divide by 2 and make sure it equals 45. All right. Have fun. Boop.